In the previous video, we talked about how to create a deep copy of a list of lists of integers. In this video, I want to show you that that particular way will not work unless it's modified for a list that contains a list of lists itself as an element. So here, for example, L contains as its first element a list of lists, happens to be just the one list, and the inner thing is the 0. So the first element of L is itself a list of lists. Here we create a copy in the same way that we created a deep copy in a previous video. What we do is we say we'll make a copy of L at 0, and we'll make a copy of L at 1, and we'll put those copies in a new list. And then we'll say that copy L is that new list. What I'm saying here is that if you modify L at 0 at 0 at 0, copy L at 0 at 0 at 0 will also get modified. Why is that? Well, here's one quick way to see this. When we say L at 0 copy, we copy the outer list, this list here, but we never create a second copy of this inner list. That creates a problem because when we modify this inner list, there's just the one of it, so it's going to get modified both when it's referred by L and when it's referred to by copy L because they refer to the same list, to this list. Let's see exactly how that happens. We'll start at line 1. The first thing that needs to happen is we need to make sure that 0 is in memory. Probably it already is. Let's say that it is at address 1000. Now we need to create two lists, both of which contain the 0, but they're going to be different lists. You cannot save memory by putting both lists in the same location because then they will be entangled. You modify one, you modify the other. So this is a separate list, and this is a separate list. Let's put the first one over here at 1000, and let's put the second one over here at 1000. Let's say that we intend for this one to be L at 0 at 0, and we intend for this one to be L at 1. Those are merely comments, of course, but this is our plan. Now that we've created both of those lists, we need to create the outer list that's still inside L. It's going to contain just the one list, this list, as an element. At 1040. 1100 refers to this list, the outer list, which contains just the one element, this list, which contains just the one element, 0. Now that we have L at 0 and L at 1, we are ready to create L. L is going to be at 1100, L at 0, and at 1080. That's what we intended to be L at 1. We can now say that the address of L is 1120. Let's move to the second line now. In order to create this new list, we need to create this element and this element. This element is just a copy of L at 0. In other words, it has the same contents as L at 0, but it's stored at a different location. Let's copy this over. And this is going to be copy L at 0. The same thing with L at 1. It has the same contents as L at 1, but it's stored in a different location. Let's copy it to this location and change this to copy L. We are now ready to create this outer list. The first element is going to be at 1140, copy L at 0, and the second element is going to be at 1160, copy L at 1. Now we're ready to say that this address will be assigned to copy L, 1180. What's left to verify is that indeed L at 0 at 0 at 0 is the same as copy L at 0 at 0 at 0. You can probably already see that it is. Still, let's verify it. L is 1120. This is L. L at 0 is 1110. This is L at 0. L at 0 at 0 is 1040. At 0, this is this. This is L at 0 at 0. What about copy L at 0 at 0? Well, copy L is 1180. Copy L at 0 is 1140. Copy L at 0 at 0 is 1040. And copy L at 0 at 0 at 0 is the same 1000. That would be because we never created a separate list that was a copy of L at 0 at 0. You can get to this very same list stored at address 1040 by way of copy L by saying copy L at 0 at 0 at 0. This is why this procedure for creating a deep copy will only work for a list of lists of things that are not lists of things that are not mutable.